We're going to wrap up our review from the midterm exam talking about derivatives. This is really the meat of the first half of this course. So let's take a look at finding some derivatives. Starting with finding derivatives by the definition. There will be a problem on the midterm that says, I want you to show your work and solve by the definition. So even if you get the correct answer in the online homework system, if your work does not support it showing it by the definition, you'll get those points taken away. So you want to make sure you know the definition of a limit, which is the limit as h goes to 0 of f of x plus h minus f of x all over h. So let's say we've got the function f of x equals x squared minus 3x plus 1. Using our limit definition then, we say that's the limit as h goes to 0 of, we're going to take x plus h and stick it in for each of the x's. So it's going to be stuff squared minus 3 times stuff plus 1. That stuff is the x plus h. Then we're going to subtract the entire function. We're going to put that in parentheses so we show we're subtracting the whole thing and not just the first term. And then we put it over h. From here, it's a bunch of algebra to simplify it, to hopefully reduce it and remove the discontinuity because we can't plug 0 in for the h. So we've got the limit as h goes to 0. If I multiply out x plus h squared, we get x squared plus, don't forget its middle name is x times h, and it's there twice. So we have 2xh's plus h squared. Distributing the negative 3 through, I get negative 3x minus 3h. Then we have a plus 1. Distributing the negative through, we get negative x squared plus 3x minus 1, watching your signs, all over h. Hopefully, this is where the simplifying starts to happen. We've got an x squared and a negative x squared. That's 0. I've got a negative 3x and a positive 3x. That's 0. I've got a positive 1 and a negative 1. That's 0, which means I'm left with the limit as h goes to 0 of 2xh plus h squared minus 3h all over h. We're not allowed to reduce until we first factor that numerator. So we're going to factor out the common factor of h from the top. That gives us the limit as h goes to 0 of h times 2x plus h minus 3 all over h. And that's where we finally get to that magic, what we wanted. The h is reducing out, removing that discontinuity. So all we're left with is the limit as h goes to 0 of 2x plus h minus 3. So we can now plug that 0 in for the h. Adding 0 doesn't really change it, and so we get our final answer of 2x minus 3. And we can check that looking at the original problem using our shortcut rules. We would have expected the answer to be 2x minus 3. So I'm feeling pretty good about that. So you need to be able to do at least one by definition problem. After the by definition problem on the midterm, all the rest we'll be able to use our shortcut formulas on. So let's try doing these shortcut formulas. The first problem we're going to do is going to be to find the derivative, d dx, of 5 times the cubed root of x minus 3 over x squared plus 7 times x to the 4th minus 9 e to the x plus 2 natural log of x. This is forcing us to use all the different derivative rules that we learned in this class. We found out that with derivative rules, sometimes we want to manipulate it a little bit. So when we manipulate this first term, before we take the derivative, an index is going to become a fractional exponent. So that's going to go into the denominator. It's 5x to the 1/3. Minus something in the denominator can pop up to the numerator, we found out, by making it a negative exponent, 3x to the negative 2. Plus 7x to the 4th minus 9 e to the x plus 2 natural logs of x. Now we're allowed to take the derivative term by term. We know with the power rule, we have to decrease the exponent by 1. So 1/3 minus 1 is negative 2/3. And we also bring that exponent out front, giving us 5/3. Minus, again, we move the exponent out front. Negative 3 times negative 2 is a positive 6x. And then we decrease the exponent by 1, negative 3. Plus, bring the exponent out front. 7 times 4 is 28, x cubed. Minus, With e to the x, that's an exponential, so we're going to use a different rule. The derivative of e to the stuff we know is e to the stuff, so we've got 9 e to the x. Plus, we've got a 2, and the derivative of natural log, we should remember, is the 2 over the x. And so that's it for our derivative using the basic derivative formulas. Now, within those formulas, there were certain patterns we found that were useful. And the first one we called the product rule. You should recognize when I have a product like 3x to the 5th times the natural log of x squared minus 4x plus 2. Seeing that this is a product, we're going to take the derivative of the first part, which is 15x to the 4th, and then we multiply that by the second part, the natural log of x squared minus 4x plus 2. Then we need to add, and now we take the derivative of the second part. The derivative of natural log is 1 over the stuff, so x squared minus 4x plus 2. And in the numerator, we put the derivative of that stuff. The derivative of that stuff is 2x minus 4. Then we go back and multiply by the first bit, which is the 3x to the 5th. That's the product rule. Derivative of the first times the second, plus the derivative of the second times the first. Similarly, we have a derivative rule for the quotients. If we've got e to the 3x divided by 4x squared plus 1. For this derivative, we'll start with the derivative of the top. The derivative of e to the stuff is e to the stuff times the derivative of that stuff. The derivative of 3x is 3. Then we multiply it by the denominator, 4x squared plus 1. Then we'll subtract, and then we'll take the derivative of the denominator. The derivative of the denominator is just 8x. And then we multiply by the numerator. And we put the whole thing over that denominator, the 4x squared plus 1. And that whole thing gets squared. So with the quotient rule, we take the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. The other big rule we have after the product rule and the quotient rule is the chain rule. If I'm taking the derivative of something like 4x cubed minus 5e to the 3x, and that whole thing is raised to the 5th power. We see overall this 5th power is wrapped around the entire function. So we treat it like a 5th power and pull the 5 out front, reducing the exponent by 1, and then keep the inside stuff the same. Nothing changes there. 4x cubed minus 5e to the 3x. Then we multiply by the derivative of whatever was inside that. So the derivative of 4x cubed is 12x squared minus the derivative of e to the stuff is e to the stuff. And then I multiply by the derivative of the stuff. So 5 times 3 is 15. And that's going to be our derivative using the chain rule. So you need to know all of your derivative properties, product rule, quotient rule, and chain rule. We also did a little bit of derivatives with what are called partial derivatives. And that was if I had a function in x and y, such as 4x to the 7th plus 2y to the 6th plus 6x squared y to the 3rd. And if I wanted to find the partial derivative with respect to x, we treat all the y's like they are constants. So the derivative of 4x to the 7th with respect to x, we pull the exponent out front to get 28x to the 6th. Plus, notice the second term doesn't have any x's on it. It's a constant. The derivative of a constant is 0. So I don't need that. We go to the next term, bring the exponent out front. We've got 12x to the 1st. And the y to the cube is a constant, so it's just along for the ride. Similarly, we could have found the derivative with respect to y. In that case, we'll treat the x's like they're a constant. So this first term, 4x to the 7th, having no y's on it is a constant. Its derivative is 0. And so with the second term, we pull the exponent out front. And we get 2 times 6 is 12, y to the 5th, plus, taking the derivative with respect to y, we're going to pull the 3 out front, 18y squared. And the x squared, being a constant, is just along for the ride on that term. You might remember we also did double derivatives with partials. So we take the derivative with respect to x twice. In that case, I just take the derivative with respect to x function, which we have on the left here, and take the derivative again. We're going to have to multiply the 28 times the 6 with the help of a calculator. That's 168, dropping the exponent by 1. Then, still taking the derivative with respect to x, we take 1 times 12 is plus 12. Now we have x to the 0, and the x's are gone, y cubed. And that's our derivative with respect to x twice. We can do the derivative with respect to x and then y. We can switch the order and do the derivative with respect to x and then y, or the derivative with respect to y and then x. Gives us the same thing either way. Let's go ahead and just use the blue equation up there, the derivative with respect to x. Now I'm going to do the derivative with respect to y. And when I do that, the first term goes to 0. And so with respect to y, I just bring the 3 out front, and we have 36xy squared. Notice that's the same thing you would get if you did the other function. Maybe try it on your own to test that out. The only one to find now is just the derivative with respect to y twice. So we'll look at that green equation, the f sub y. Taking the derivative, we pull the exponent out front. 12 times 5 is 60. Y to the 4th as we decrease the exponent by 1. And on the second term, again, treating the x like a constant, taking the derivative of y, we get plus 18 times 2 is 36 y to the 1st. And that x to the 2nd is along for the ride. And that completes our second derivative. This video took a look at a review of all the derivative formulas, quotient rule, product rule, chain rule that you need to know for the midterm exam. It is now your turn to practice some of these on the review assignment. And then I wish you the best of luck on the midterm exam.